Hello everyone, welcome to Digital Communication Tutorials. In this video, I'm going to take up the third numerical on waveform coding techniques. Please note, this is a numerical on PCM as well as delta modulation. Let me read out the question first. The part 1 of the question says, find the output signal to noise ratio in a delta modulated system for a 1 kHz sinusoid which is sampled at 32 kHz without slope overload. The bandwidth of the reconstruction filter used is 4 kHz. Moving on to the part 2 of the question. If the data rate of the above system is 32 kilobits per second, which is the same bitrate obtained by sampling at 8 kHz with 4 bits per sample in a PCM system, find the average output signal to noise ratio of a 4-bit PCM quantizer for the sampling of a full scale sinusoid with Fs equals 8 kHz and compare the result with the previous problem. Please note, when I say previous problem, it is with respect to part 1. Let us start with the solution part here. So, going back to part A, we note that we are given a delta modulated system and we have a sinusoid of 1 kHz. So, when I start with part A, the sinusoid frequency is represented as F0 and is equal to 1 kHz. Then, it is sampled at 32 kHz. So, the sampling frequency Fs is equal to 32 kHz. Lastly, we are also told the bandwidth of the reconstruction filter used is 4 kHz. This is represented by Fm and is equal to 4 kHz. The numerical also says the system does not experience slope overload. So, as per the part 1, the output signal to noise ratio of a delta modulated system with no slope overload is given by SNR output equals 3 into Fs cube divided by 8 pi square F0 square Fm. I have derived this expression in my previous video. I would like you to kindly refer to that video. So, let us substitute the values of F0, Fs and Fm here. So, SNR output is equal to upon simplification, this is equal to 311.25. No unit because it is signal to noise ratio. However, let us now represent this in terms of dB. So, the value of SNR output in terms of dB is given by, the expression is simply 10 log 10 of SNR output. So, this is equal to 10 log 10 of 311.25. This is equal to 24.93 dB. That is the answer for part A of the question. You can come back and look at the part 1 here. We are asked to find the signal to noise ratio of a delta modulated system under the condition of no slope overload. That is why I used this equation. Let me call it as equation 1. Right, part 1 of the numerical is done. Let us now move on to part 2. In the part 2, we are once again asked to find the signal to noise ratio, but now of a 4-bit PCM system, pulse code modulation system. We are told that the quantizer used is a 4-bit quantizer. So, when I start part 2, we identify the value of the number of bits of the quantizer, which is n, and this is equal to 4 bits. Now, either I can assume a mid-riser quantizer or a mid-thread quantizer. Let me take a mid-riser quantizer. So, I will write assuming mid-riser quantizer. The SNR output in terms of dB for a mid-riser quantizer is given by 1.76 plus 6n, where n is the number of bits of the quantizer. Therefore, this is equal to 1.76 plus 6 multiplied by 4. This reduces to 25.76 dB. This is the answer for part B of the question. Also, at the end of the part B of the question, we are asked to compare the outputs of the delta modulated system and the PCM system. So, if you look at the SNR output for the delta modulated system, you see this is equal to 24.93 dB, whereas the same for the PCM system is equal to 25.76 dB. So, what now I will do is, I will compare equations 2 and 3 here, which is the SNR output in dB for delta modulated and PCM system, and conclude that even though the delta modulated system is a lot simpler than a PCM system, which is supposed to provide advantages over the SNR, we find here that the PCM system has higher signal to noise ratio. Therefore, the PCM system provides better performance than the delta modulated system. That is what is the conclusion from this numerical. I will write that down here. Right, that is the conclusion of this numerical. Well, with that we have come to the end of this video. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.